Hello and welcome, and thank you for joining us today. This webinar is part of our Industrial IT webinar series. My name's Phil James and I'm the Availability Product Manager here at SolutionsPT, and this morning I'm joined by Andy Graham, who's a Wonderware Product Manager. The title of this webinar is Ensuring Continuous Availability for Wonderware System Platform 2017. And really what we're going to cover this morning is, firstly, I'm going to highlight some of the market trends that we're seeing in the marketplace today. They're going to be centered around the drive for collecting more data and how we store that data, particularly with critical systems. So then I'm going to talk about Stratus ftServer, which is a way that we see as a solution to some of the problems that we're facing. I'll provide an overview of the Stratus ftServer, and then with the introduction of the new machines that Stratus have brought to the marketplace, I'll also take a look at some of the comparisons between the new generation and the older generations of ftServer. In tandem with that, what I'd like to do is to briefly run through virtualization and resilience and how that fits together, especially with the ftServer. As I said earlier, we've got Andy Graham joining me here today. So he's going to provide an overview of Wonderware System Platform 2017. In tandem with that, what we would like to do is to share the key benefits of deploying a joint architecture with Wonderware System Platform hosted on a Stratus server. Following on from that, we're going to share some of the added security benefits of our disaster resilience service. So heading over to the market trends, what we're seeing at the moment is the importance of availability. Earlier touched on the drive for more data and how that fits in a critical infrastructure. So I'll just let you take in some of the words from that slide. And whilst you do that, during this webinar, we're going to talk about terms such as Internet of Things, Industrial Internet of Things, and the Edge. So I'll just explain what we mean by those terms. So the Internet of Things is an idea that there's going to be more and more intelligent devices all communicating with each other and back to the Internet. Those devices are going to generate lots of data, and that data could help sort of shape our lives and improve our lives. So things like wearables, self-driving cars, that kind of thing. And what the Industrial Internet of Things is the same ideology, but in the industrial setting. So data that can help us make more intelligent business decisions. And when I refer to the edge, what I mean by that is that the data that is being generated from these devices, that data being stored, computed and analyzed at a local level and local to those devices. So what we're seeing is that there's more of these devices now in the world today. The trend is that we believe that there's going to be more of these devices in the future, and the data that comes from these devices is going to be more critical over time. So surely people want to protect that data and keep the systems that store that data more available. So here's a graph from the IDC, some of the research that those guys have done. And we can see there that there's a huge trend of increasing amounts of data that is going to be collected and stored. So in 2015, there was 16 zettabytes of data globally that we generated. And you can see there that by the year 2025, we're predicting that there's going to be 162 zettabytes of data, so a huge increase. To put that in contrast, in 2019, there's 40 zettabytes of data, so that's only a year away. But what's interesting is that 40% of this data is expected to be collected and computed locally at the edge level. But what we're also seeing is that the IT budgets in the workplace today aren't changing. So here on this graph, you can see that there is a 10-year span, and the figures are very, very similar. So around 70% of the IT budget is spent to keep systems up and running, you know, generally keeping the lights on, so general maintenance. So that's only leaving about 30% extra for everything else that IT departments want to deal with. So when you imagine that there are new initiatives and drives for improvements for things like cybersecurity, it means that there's less and less budget available for keeping these edge locations or these edge computers, edge facilities up and running. So that's made us think about, you know, what are the solutions to these problems where there is less budget available for systems at the edge, but there's more importance to keep this data up and running and supporting critical systems at the edge. So I'm sure that some of you are aware of Stratus ftServer, but I'd like to just give an overview of what it is and how it can help address some of these problems. So the ftServer is a truly downtime prevention system. It has 5 nines of availability, which is 99.999% available, and in some cases better than that. So if you were to open up an ftServer, what actually is it? I mean, what you'd see is the same x86 architecture with the latest generation of Intel chipsets. But what's different is it's 2 independent slices. So you can see from that graphic there, it's 2 servers in one. But what makes it really unique and how it achieves this sort of unrivaled availability is the automated uptime layer, the active service architecture, and hot swappable customer replacement units. So the first thing I'd like to talk about is the automated uptime layer. So this is unique to Stratus. It's hardware and software. So there are identical proprietary FPGAs in each slice. And what they do is they run proprietary software, firmware, that keeps both slices of that server running at exactly the same time. So each computing task is running fully in sync with each other. So rather than trying to recover from a failure, what Stratus can do with the ftServer is prevent that failure from ever happening. Because rather than failing from one slice to the other, they're both running at exactly the same time. So if a component fails on one slice, the other slice just continues to run. It does not fail over. Applications that live on the ftServer see it as one logical machine. So that means that you don't need multiple applications, multiple copies of applications. You don't need multiple operating systems, and you don't need any custom-built operating systems. This is the standard OSs that you would see on the latest office-grade machine. Because the lockstep technology means that there isn't any failover, it means that we don't lose any what we call in-flight data. We don't lose that in-flight data. So I'll talk about some other high availability solutions later and compare that against the ftServer. But what they're trying to do is to try to recover quickly from a failure rather than truly prevent downtime. And then we move on to the active service architecture. So every ftServer comes with a comprehensive support package. So rather than the traditional break-fix model that you may see elsewhere, what Stratus do is have an active service architecture. So that starts firstly with the machine. So the ftServer is very intelligent in that it self-monitors itself. So it's continuously checking key parameters, and then it has a system diagnostic tool. So what it can do is it's obviously self-checking itself, and you can even have it set up so that if it wants to take a subsystem offline, if it sees a permanent failure, it can do that for you. And then we have the call home functionality. So what would happen if that subsystem had been taken offline or the system notices that there's a permanent failure? The ftServer will automatically call home and it will call for replacement parts. So if you imagine we've got two slices to this server and a processor failed in one of the slices, rather than just sending out that processor, we're going to send out a fully built slice that includes all of the memory, all of the processing power, all of the hard disks. That will turn up the next day to where the ftServer resides. And it's really simple in that you don't need experienced IT staff to install these replaceable parts, these slices, if you will. So it's a very easy process whereby the slices can be switched over. And once that happens, the system is intelligent enough to resync itself, so it puts itself back in duplex mode, and then the system is fully functional again. And then we have these hot swappable customer replacement units. So as I mentioned earlier, they're so simple to replace. So if a slice is to go down, there's a failure that happens on one of the boards, the server continues to run. There's no loss of service, there's no loss of data. Within 24 hours, a new replacement slice is received. And as I mentioned, it's very easy for an engineer or a member of staff to swap out these slices so that the system can get up and running really, really quickly. And obviously this helps to minimize downtime. So let's look at some of the other ways that people look to increase availability. So we're going to start with standalone server, second on the left there on the table. So if you imagine this is a single machine, so it's a single point of failure. It's never designed for high availability. So if a server goes down and this is the one standalone server, then you can imagine that you're suffering downtime as soon as that occurs. You need to wait for an engineer to come out and fix a machine, and hopefully you can do that as soon as possible. But it isn't really designed for these edge locations where availability is a real big factor. So then we move on to HA clustering. So what this does is it adds another server, or you'd need at least two servers to implement this solution. And with that, you'd need at least two networking appliances, some sort of shared storage or a SAN, and obviously there's high costs associated with that. Then you'd need to make your applications cluster aware. You would need to create some failover scripts so that if one server fails, it automatically fails over to the other machine. So with this complexity, especially with the level of IT staff that would be needed to sort of manage and maintain this infrastructure, with this complexity and increased cost, you're still only trying to recover quickly from a failure. You're still going to suffer downtime. And as I alluded to before with in-flight data, if one of these processors stops, any data that isn't committed to disk is likely to be lost or corrupted. And then we can move on to virtualization on the far right-hand side. So this is similar to HA clustering, but you're using a virtualization platform combined with the same, at least two servers, at least two networking devices, and some sort of shared storage. But again, at best, all it can do is try to recover quickly from a failure. If we compare that with the ftServer, it's the only system that's going to provide 99.999% availability and offer true failure prevention. So it doesn't need complex scripts to be written for failover. It doesn't need applications to be made failure cluster aware. And we're using standard Intel chipsets, standard operating systems, and as I said, the applications see the server as one logical machine, so there's only one version of the application, one version of the operating system that's required. So let's take a look at the comparisons between the new and old servers. So this table here is the new ftServer that was released in July of 2017. So you can see here that we've got 3 levels of system. So there's an entry-level system in the 2810, which will likely run around 7 virtual machines. It's got a single 10-core processor, and it runs the latest versions of Windows Server 2016, you know, the latest and greatest operating systems. And then we move on to the 4810, which is a mid-tier system. It's got a 2-socket 10-core processor. And then we've got the high-end tier, the ftServer 6810, which will likely run in excess of 20 virtual machines. So what's new in ftServer, the latest generations of servers on offer? They offer better performance, so they have the latest Intel Xeon E5 v4 processors. They support up to 1 terabyte of super-fast DDR4 RAM. We've got enhanced availability. We can now make use of Intel's Rapid Start technology, which means that if you have planned downtime, the system can boot up 10 to 20 times more quickly. So it means that that planned downtime is going to take less. You can get back up and running as quickly as possible. There's also an SNMP alert, which periodically reminds system integrators or end users that the system is in simplex mode. So one of the slices isn't running correctly to minimize downtime. And then we've got improved manageability. So the automated uptime layer is now fully downloadable from a secure Stratus FTP site, and it means that you can, it's far easier to upgrade your machine if required. So this is a comparison between those 2 generations of servers. I've put this slide in here mainly for reference if you guys want to come back and look at the technical details in more detail, then that's why this is here. I mean, it'd be good to just take a look at the mid-tier system. You can see here there's the 4800, which is the Gen 8 machine, against the 4810. So what we're doing here is we're going from a single socket 12-core machine to a dual socket 10-core machine. So it means that the threads have increased in the system from 24 to 40, which I'm sure Andy will get onto in a second. It means that traditionally maybe we'd have had to look at the 6800 before these machines were available for some of the larger critical systems, but really with the introduction of the Gen 9 servers, it means that maybe we could look at the mid-tier system, which is obviously reducing cost for supporting these critical applications at the edge. So next, what I'd like to do is talk about virtualization. So when you virtualize, or when you combine virtualization technology with the ftServer, you know, it's such a powerful solution. So I'm sure that some of you are aware of what virtualization is, but just to give a bit of background and prepare you for Andy Graham's presentation in a second, I think it'd be good to just go over what virtualization is in case anybody isn't aware. So virtualization is a technology which essentially allows you to abstract the software from the hardware layer. So if you imagine on a standard physical server, you've got a CPU, network interfaces, RAM, and an operating system. When you introduce virtualization, it allows you, with the introduction of a hypervisor such as VMware or Microsoft Hyper-V, it allows you to then provide virtual instances of multiple machines on a single physical server. So that provides lots of benefits, and a few of those are IT cost reduction, in that you can consolidate multiple physical machines into virtual machines living on a single instance in some cases. They're easier to manage and support. There are reduced operational costs, reduced development costs, and it fosters collaboration. In that, since multiple installations or multiple instances of a virtual machine can run at the same time, developers can work in a more collaborative and efficient manner. So now I'd like to pass you over to Andy Graham. He's going to talk about System Platform and how the ftServer can fit in a Wonderware architecture.
Thanks, Phil. Yeah, so I just wanted to cover a brief overview of System Platform, just for, I realize obviously this is an industrial IT webinar, and maybe people on the call that don't know what it is. But for those of you that do know Wonderware, you'll know that they are the market leader in HMI and SCADA solutions, so you'll find us in about a third of the world's plants. So it's a pretty big brand, you know, been around for a very, very long time. InTouch, you'll probably know a bit more commonly as the SCADA or HMI we've used previously. That's obviously still around today because we've got such a big install base. That's been around since 1987. System Platform was introduced in 2003, so it's by no means a mature product. We've just made some real leaps in terms of our capabilities with 2017, which is the reason why we're really talking about this. But just some of the headline things for Wonderware and System Platform, and Wonderware are renowned for their ease of use, from the different types of people that get involved with it, so your engineers, your contractors, might be application specialists, they all find it an easy solution to use. Wonderware pride themselves on making sure they have design concepts built throughout the entire platform. So we call it situational awareness. You may know it better as high performance HMI. There's lots of different things, but what they provide us with out-of-the-box development libraries, reducing your engineering time. So what I'm not saying is that you can't do this with any other SCADA platform out there. You can, by all means, engineer pretty much anything into a SCADA application, quite flexible. The point here is that they're providing so much out of the box is that the reduction in engineering effort is dramatic. It's huge. They have lots of different ways to manage the application, and this is only helped when we start to look at centralizing our solution in something like a Stratus server. But they allow for things like centralized development, so you can have multiple users connecting to the environment at the same time. It's all completely audit tracked, so you can see what changes people have made as they've gone through that system. And they're getting more and more scalable. So the idea with a Wonderware environment is that you can start small and grow with your plant or enterprise. So it may not just be a plant-wide, I'm increasing a line. It may be the case that actually I'm starting on one plant, but I'm moving up to 2, 3, or 4 plants as we go along. This architecture here just shows you some of the software platforms that exist in the environment. So System Platform very much sits in the middle there. As you can see, we have operations integration that connects down to our assets or devices. And for the entirety of the Wonderware platform, it's never been tied to a PLC vendor. So we're effectively PLC agnostic, and we will stay that way. We do have drivers and things that connect to all the big players in the market, but now really what I like to say is that we're now becoming device agnostic, because we're starting to see these weird and wonderful devices that are coming on the market, these low-cost sensors, this IIoT that Phil was referring to before, you know, the way to introduce non-intrusive sensors so that we can get more data out of our systems. We can connect to even things as small as things like message queue telemetry transfer, MQTT. So we're talking about very low cost, very low powered devices. And whereas Phil referred to as the edge earlier in some of his market trends, and how Stratus can be the platform for that edge, System Platform is essentially the apps and analytics layer that sits on top of that platform to be able to do the calculations and things it needs to do locally before you send it out to a wider environment. And that's where we can start to see this hybrid cloud come into play. So we can get data from any of these layers here that we see send it up to a centralized cloud environment in a hybrid approach, and it tends to be data that we're seeing as the shift here, because people don't want to offer SCADA or control from that environment. It's just doesn't seem to be feasible at this stage, but data certainly is. So once we get it there, get it from the edge up to that cloud environment, we can then make it available to whoever we want to, because it's so flexible in that regard. Then if we look at the scalability and how this has come on, so yes, we've always been able to engineer and develop so that you can grow as your plant starts to grow. But with this latest development and the developments over the last few years, we can now get much more throughput through a single box. So there's a good example here. Wonderware tested their 2017 release running a 8-core machine with 32 gigs of RAM, a 500 gigabyte hard disk. They were actually getting 100,000 I/O through that single box. So many of those tags were historized. They connected into loads of different types of PLCs. There used to be a bottleneck a few years ago in that we could only probably get about 25,000 I/O through a system. That bottleneck was the drivers themselves communicating to the PLCs. So what they allowed to do was use multiple cores on the PLC. So you spread the load across multiple cores, you get more throughput. So now we can do about 100,000 I/O. From a client perspective, now this isn't referring to Untitled System Platform, as you may know it with System Platform. We are referring to the InTouch OMI, the Operations Management Interface client. So what they did was get 20 RDP clients through, again, a single server, all running this in a standalone single environment. Then if you wanted redundancy, you add a second machine, and away you go. Then if we get on to a bit about the architecture and delivery, so we've got a very simple architecture on the right-hand side there with the Stratus in. But what we do have in terms of how we do joint delivery for these things is a systems architect team. These guys are experts in pre-sales activity, pre-sales delivery, and they'll provide you with support on how you might architect a solution to the requirements and needs of your project or whatever it might be. These days are often, or for the last few years, are often seeing Stratus including pretty much the default in these architectures, because people can see the real benefits, the real cost savings you can make from not having to have all the expertise in-house about having to create clustered environments in a virtual scenario that still isn't to the fault tolerance level of a Stratus. So we're seeing some real improvements in the way that people are wanting to protect their environments. As Phil mentioned earlier, the way that the data and the downtime is becoming more critical. So this is really important to involve our systems architects when we look at things like resource allocation tables. So what they'll provide you with is, based on your requirements, the number of virtual machines you might be running on that Stratus. They'll provide you with the exact amount of resource that you need per virtual machine, but also include the amount of overhead that you might require. So overhead in terms of perhaps planned expansion for the future. You add another virtual machine to do something slightly different. You know, you've got an MES module you want to bolt onto System Platform later in the day to do something else. It could be unexpected. You might have additional engineering that you didn't quite expect, or as an SI, your end user requirements have changed. And in some cases, it could be bad application design. We do come across it, so by introducing that expansion and that headroom availability, that allows you to accommodate for that. As part of this, we also offer installation services. So this means that you can actually receive a Stratus server fully configured with everything on top of it. So the hypervisor layer and Wonderware support VMware and Hyper-V as a standard. And then all the virtual machines that sit on top of that, all the software installed, all the licenses, etc., etc. They'd even go down to configuring things like virtual switches on the hypervisor, and also the number of network cards you might need in the virtual machines for things like redundancy, because they have to go across 2 different subnets. What that means is that you can start developing straight away. So you get the server, you receive it, you log into it, and you can start to use it. Then if we just go back to what Phil mentioned earlier with regards to improving the resources, and you've hopefully seen some of the improvements we've done from a scalability perspective in terms of system platform, we can now got a lot more for less from both angles. So that could mean that where Phil mentioned in the past we may have had to gone up to the largest Stratus server to deliver a very large application, because you know our system platform environments go up to 1 million I/O if you wanted them to. We can now get more for less inside of this single environment. So this hopefully covers some of the benefits of, in this brief overview of a joined-up delivery of a solution like this. Means you don't have to worry about support for all those products involved. So we'll let us worry about whether the hypervisor supports the versions of the OS and the Wonderware versions you're running on top of it. That is our guys' internally job. Then one thing that we haven't discussed is around the disaster recovery. And in our managed platform Proteus service, we do provide a business continuity solution. And this service utilizes a hybrid deployment, so it's very similar to what we talked about before with the hybrid cloud, so you can have that on-site vault for local storage. The reason you might need something like this is because, yes, the Stratus server is fault tolerant, so you're doing a great job there in making sure you're keeping it up and running. But what if you have a real critical scenario, perhaps a fire or a flood in a server room or control room, and we lose that Stratus? It's incredibly important to make sure we have those backups off-site. The other topics on your mind might be related to things like security. So security, again, is a huge topic, and it's important to have the right protection if, for any reason, this system was compromised. I mean, one of the benefits of moving to a centralized management solution in a virtualized infrastructure is that you only have one place to go to configure everything throughout your solution. The obvious downside to that is that you have to make sure that hypervisor layer is protected to the nth degree. So there's a lot of things you have to go through to make sure you've got the right layers, zones, and conduits throughout that single environment, because if you compromise that bottom layer, there's a chance that people can get into that solution. And one of the things that we're seeing these days is very much to do with the ransomware problems throughout. We've seen lots of attacks that are hidden in our industrial market. This solution has something called ransomware detection actually built into the system. So it'll analyze whether ransomware is part of the backups. Our central managed services team will be notified of that so that we can let the SI or end user aware of any potential infection. This allows you to take remedial action so that you can go back to a point in time when that ransomware didn't exist in the system. And then lastly, they also have something called backup verification. So lots of our customers do actually carry out backups. The problem here is that they've never been in a critical scenario where they've had to restore it, so they've never actually checked that that backup would be functional and be working. This does an automatic check of the backup, provides a screenshot of the Windows login prompt to make sure that it will work if you do see that scenario. So then lastly, just to summarize, hopefully you've seen from Phil's presentation that the Stratus servers are constantly getting more powerful. We are getting much more for less. There's now 2 sockets in our mid-range service, so we get many more cores. Obviously, we can have so much RAM inside of there to be able to provide a great platform to deliver a very large solution. And in terms of system platform, because we are now more scalable, we can get more through a single box. We can introduce more on a single server. Our experts in the office, our systems architects, our pre-sales delivery, our installation services, it's a great resource that you can use to be able to understand things like resource allocation for your Stratus, to understand which Stratus you even need for your environment based on the project that you're looking at. And then lastly, really just an importance about that disaster resilience in there, and to make sure that you have some sort of disaster resilience in place in the event of some sort of catastrophic failure. throughout your plant. So with that, we'd just like to go and see if there's any questions, and I think we've had one on the chat.
We have, yeah. I'm conscious that we've run over time as well, and we don't want to take up too much of your day. We understand that you're all busy at work. So we'll just read out the first question. So, do ftServers require installation in a server room controlled environment, or are they suitable for office or control room environments? So what I'd say to that point, I mean, it's a great question, is that we have many customers who run ftServers in a multitude of different locations. But I'd maybe go back to Andy's point. The ftServer is renowned and best in its class for presenting downtime, but if you are going to consolidate these critical systems onto one box, you know, we do encourage people to have, or at least consider, a disaster resilient solution. We've put some contact details up on the screen for you. If you do have any further questions or you need further information, or you want to reach out and have a chat, then please use the contact details provided. So I'd just like to thank you for your time, and we'll look forward to seeing you again on the next Industrial IT webinar. Thank you.
Thanks, guys.